Hi, my name is Anna from U of H KD campus. Our NA challenge is making solar energy more efficient. Solar energy is facing three main challenges. First one is efficiency. The second one is the cost, and the third one is storage, the way to store solar energy. Our group developed a code that will calculate energy output of solar panels made with different materials and their alloys.
Hi, my name is Dorothy. This code aims to determine which materials would produce the most energy, and one, by calculating the energy output of a given panel, given its dimensions and material efficiency. As an option, the user can estimate the energy output of an alloy of materials. Using an example of a city in Canada, the code can use data from various solar energy stations to calculate the maximum or minimum energy produced by each station.
Hi, this is Abdurrahman. So talking over the script, it's split into two problems. The first one, we are using a gathered data for different cell sizes and efficiency, which the code then will determine the estimated energy production for each solar panel size that the user inputs. For the second part of the script, the code will calculate the maximum, the minimum, and the average energy usage for a city in Calgary in Canada.
Hello, my name is Kevin Espericueta, and I'm here to explain the flow of our program with the following flow chart. Our flow chart, the ovals represent the beginning and the end of the program. The flow lines denote the direction and logic flow in the program. Our parallelogram denotes either an input or an output operation. The green rectangles denote a process to be carried out. So, for example, any calculations that had to be done on the background. The purple diamonds, they represent where a decision had to be made between continuing the program or repeating the process.
Hello, this is Ariba. I'm going to explain the output for problem 1. The output displayed for problem 1 is in the form of a bar graph. Here it displays energy outputs for the cells using the user entered length, width, and height. If the user chooses to view energy outputs for all materials, in this example we can see, looking at this bar graph, that cell GAAS produces the highest energy output, and cell DSC produces the lowest energy output.
Hello, this is Benjamin Ilbudo. I'm going to be explaining the outputs of our problem number 2 on the bottom right of our PowerPoint. So the users have a choice of calculating the average energy produced in Calgary, the maximum energy produced, or the minimum energy produced. This output shows an average energy over a location based on the user input, and it shows the average energy of these locations. And of course, Bears Plant water treatment plant has the highest average energy produced, and Thetis Park has the lowest energy produced.
So overall, this code can be used by a user to determine which materials they want to incorporate in their solar panels. They can choose the highest producing material. In this case will be the GAAS, and pick any other of the other materials and make an alloy, and probably at that point they will ensure a highly efficient solar panel. The second part of the problem just helps us to incorporate all that we have learned in this class, in all the skills that we have learned, to calculate the maximum, the minimum, and average energy produced based on a huge data set.